Now we will talk about fork system call. Fork system call is a system call which creates a process or which creates or duplicate a process. For example, we have this program from the previous section of the lecture. Now I will execute this program. So I will navigate to the directory where this program resides. So here this program result which we have written, welcome program. Now I will execute this program. So this program has been executed. This program has compiled. Now I will execute this program by writing ./welcome. So welcome to OS Lab. So this is the output of this program. Now I will use a fork system call. Fork system call, what it does. So I have used fork system call. Now I will save this and I will compile it because I have changed the program. Now I will compile the program. So here I have got an error. I will rectify those errors. So the error here is curly braces. Now again I will save it and I will compile it. So we have no errors but a warning. A warning because this fork needs some of the libraries to be included, but this is not an error but a warning. Still the program will run. So I will run the program. So here we got two messages, welcome to OS Lab. If we look at in a program, so we have written only one. What fork does? Fork duplicate that program. Means that after fork two programs are running. So this is the function of a fork call. So we will include a library here so that it doesn't give us any warning. Now I have included that library, this library, so and I have to compile it. Now it doesn't give us a warning and I will now execute this. So here we have got two statements. This means that the fork has cloned this program. We have two programs. Now we will see that what actually it does. I will modify the program. I will write here printf, and this statement is before fork, and here I will write this statement is after fork. Now let's see what this gives us as an output. I will save it. Now I have to compile again because I have changed the program. So no, look, this statement is before fork, this statement is after fork, this statement. So the statement after fork is printed 2 times. So when a fork is called, fork system call is called, so it duplicate the rest of the statements or whatever in the program. It duplicate it creates second process. One process is this one which is running, and the other process is created by a fork. Now I will told you about the flow of the fork, how it works. When we execute this program, then it will execute normally till this point. This statement will be printed. When a fork is called, it will duplicate, it will create 2 processes. So one process will print this statement one time, and the second process created by fork will print this with second time. Now here this is your task, that add another fork here and see what happens. So this is the flow of the fork. Now we will see that what actually forks do and what it creates, fork creates. Now we will talk about the technical procedure of the fork, that what forks actually do. When fork is called, it will produce 2 values. One value will be 0 and the other value will be its PID. It creates these 2 values. Now we will see that how it creates these 2 values. So I will modify this program. So here P is equal to fork, and I will declare P as integer P. Now P is equal to fork if P is equal to 0. So we will see this is a child program, child process, and else if P is greater than 0, then this is a parent program. So it will now create no, we will see what it gives us. Now I have written this program. I have declared P as an integer. P is equal to fork, so the fork will produce two values. One is P is equal to 0, and the other one it will produce a value greater than 0. So it will produce two values. When there is an if and else statement, so one of the statement runs and the other statement does not run, but here in this case, because this fork are generating two values, so both these statements will run. So I will have to compile this program. And now I will run this program. So you see, this is a parent program, this is a child program. So both the statements has been printed because the fork produce two values, one value equal to 0 and the other value is equal to is greater than 0. Now I will modify this program and we'll see that actually what is the value of P here in a child process and what is the value of P here in the parent process. So here I have modified this program. Now we will see the value of P. I will save it, and now I will compile it and then I will run this program. So this is what 151 is the value of P in parent process and 0 is the value of P in child. So this fork generates two values, one is 0 and the other one is a positive integer. Now as the fork creates two processes, so here we will see by using system calls get PID to know the process IDs of those processes which fork has been created. So here we will write those functions get PID. So it will give us the the PID of the child process which is created by fork, and here we will write get PID of the parent process. So this is a get PID system call, which we can get the PID of that process. So this will give us two PIDs because the fork has created two processes. So I will save it and then I will compile it. So there is an error. Let's see what error we have got. We have got this error, and now I will save it. Now I will compile this program. So see that 167 is the value of P in parent process, 168 is the value of P in child. So these are two processes. One is parent process whose PID is 167, and the other one is child process whose ID is 168. So these are two processes which has been created by fork system call. Now I will again modify this program. Copy, Control V. So here I will write get PPID and Control C and write here get PPID. So this is, let we have to comment, this is a child process, and this portion will create a child process, and this portion is creating parent process. Okay, so I have comment this. No, just see here this get PID will give us the PID of the child process, and this get PPID stands for get parent process ID. So it will give us the PID of this process, which is the parent process to this child process, and this get PID and this get PPID will be same, because this is the parent PID, and this is the parent process PID, and this is the child process of this parent process. So it will get the parent process PPID. So this value and this value will be equal, and this value we will get the parent PID of this process, which we don't know, or which is the terminal which executes this program. So I will save it. So commenting in C is like this. We have commented this with slash asterisk enclosed with asterisk and slash. Now look at this program. I will compile this and run this, and we will see what we have got. I have compiled it, and now I have run it. So see that 2000 is the value of P in parent process. 2000 is the value is the PID of parent process. 2001 is the value of P in child. 2001 is the PID of child process. 8 is the value of P in child, and 2000 is the value of P in child. So 8 is actually the parent of the parent process, which is bash. If you look at this, so 8 is the PID of the bash process. Now we will see the program. I will modify it, and then we will see the results. Now look at this, it will now be clear. If P is equal to 0, it will create a child process, and this this function will give us the PID of a child process, and this will get us the PID of the parent process of a child. So this is the parent process of a child. So this and this will be equal, and this will be the parent ID of the parent process of this parent process, which is bash, which is that terminal. Now I will save it, and then I will compile it. Now look at this. This is the parent process by PID in parent. Let's let I bring this value to the end of these statements. It will be then more clear. Now see, this is the parent process by PID in parent. This is the child process PID. This is the parent process ID of the parent process 8, which is bash, and this is the parent process PID in child, which is 216. So this is what we have got, that the parent PID is 216, the child PID is 217, the bash PID, which is the parent of all this process, is 8, and this is the child this is the parent process PID in child. So this is like here, this is the parent process PID in child. So get PPID, and these two values will be equal. This value is of child PID, and this value of this is the parent ID of the parent process, which is bash.